I did a background like box where it just randomized the colors. I thought, and Muyoung, go ahead and like use the arrow keys to increase and decrease the values. Like our understanding of the assignment was, when we change the parameters, the image should change. So to show that, go ahead and use the arrow keys. Muyoung, just spam some arrows.
Whoa.
No, not yet.
There's a technical difficulty, I'm sorry.
Come on. Spam your arrow keys.
Okay.
There, yeah. Right and left too. Just spam everything. Just show them.
Okay.
Move around. Yeah, you can move it horizontal and then and then use the up key, Muyoung. Yeah, and then like basically the back boxes changes as well with the variation, and you can make me like really small as well. Go ahead and press the bomb, like arrow down, Muyoung. So it's all relative. Just keep on pressing. Yeah, there you go. So everything's relative to the arrows, and I just move around the screen for fun. So that's my interpretation of the homework. How we use parameters to make the image not stagnant, and it's all like recalculated every time based on the parameters. And then go ahead and Muyoung, show your half of the portrait.
All right. I have two functions. One is drawing the background collage. I used 4 different filters. I borrowed those codes from our textbook. And then another function is drawing my self-portrait. So I made it translate and scalable. And I used the if conditions to animate this and to prove that it's scalable. Any questions?
That's awesome. Yeah, you guys did a great job as well.
So yeah, it plays music in the background as well, and like when we click the cursor, which we won't do for now, it changes the music. But basically, it's like the concept of this is like a countdown clock for like New Year's, where when you do click it, it says Happy New Year's, but not yet. So for now, we have the kinetic art in the middle, where we recreated from the YouTube video. And then we have the sine wave from the SMU. And then go ahead and play around with the controls, Muyoung, with setting it so that...
Okay. Yeah, so this is the front view of the wave, and we can rotate along the y-axis and x-axis. Yeah, so... yeah.
Manipulate it.
So I made... okay, go ahead, Joe.
Go ahead and manipulate it to the heartbeat model, if we can make it, like -18 and -0.8,
right.
-0.8, if you could do it. But anyways, we have like an oscillating like generator where it changes speed from like spin rate of 7 and back down to 1. But this is just like the same sine curves we saw at the bottom, but we manipulated the scale where like it shows like a really cool like 4 like it's like the 4 sides are all like what's it called, symmetrical. So like because of that, we have like some really cool like illusions when we manipulate the scale and then tilt the axes. So yeah, these are still the wings of the original sine waves, but we just changed it so that it looks like this afterwards. So you could just play around with the controls. And then obviously
awesome
yeah. So yeah, there's like a lot to it than the presentation itself. So yeah, this is a rerun. So basically the colors are contrast to each other. They're like opposite on the color wheel. And then we have a countdown clock where it shows the real time, which is like 9:03 or something. And then go ahead and click on the cursor, which is, it says countdown clock now, and then when you click on the cursor, it says Happy New Year. So like it's supposed to like, you're supposed to do it, and then like on New Year, when to celebrate the New Year's, and then like keep on clicking at Muyang. We just like borrowed some code from I think the professor, where like it's a particle generator to like make some sparkles on the screen. So we just did a lot of stuff. It's supposed to be like a portrait where you can also like import a picture as the background, but we left it as a contrast for now. But yeah, that's what we did.
That's awesome. I wonder if just because when it starts cranking up and you have it like those bars, like the SMU wave gets really big, it's really cool looking. I'm wondering if that clock would be more subtle if it was just like almost like a digital display in the background or on the bottom or something like that. You know what I'm saying? So a little more subtle. The clock part.
Yeah, we could do that. We were just trying to have the clock for now follow the mouse cursor. So that was the intention of like having all the elements of the clock, the analog version follow the mouse. So that was our intention of like keeping it intact while it showed the right display on what time it is in real time. I'll run it real quick. Well, we decided to do the data import as suggested. We put it in a TSV file, and then it's pretty basic if you look at it. It's just date, and then we removed the title columns, but basically it's precipitation and temperature. So when we run it, we made it like a dashboard. So real quickly, the data's here. So when you go over it with your mouse, it changes. Like it changes with temperature, and we were trying to see if there's like a trend when it comes down to how much rain and versus temperature there is. And I guess it's like kind of like a bell curve thing. And we made some extra stuff where we could like zoom in and zoom out on the particular dots, especially if the dots are really together. And then it shows like what day it is. So that's what we ended up doing for the portion of the data import of the dashboard for rainfall and temperature over time. And then for the other part of the dashboard, we made like a misery map almost, where if we highlight here, it's like Atlanta, and you can see it's like, it's windy, and there's like a tree with some wind at 34 degrees Fahrenheit, ATL for the major airport. And then it says, this data is like, we just made it up on the spot, like on time, delay, and percent canceled. And obviously it's equivalent to like 100%. We were gonna like put some lines in between the different airports to show like which ports have like more cancellations or delays, but it just became really like convoluted. So we just decided to do something simple. So go through the different iterations of the airports. So it's like sunny, snowy. This is Detroit, this is rainy. I mean, these weathers are probably fake, but, and then this is like, Dallas, it's like windy and like snow and, just all these like different forecasts. So we have like 6 different types of weather when it comes down to the animation for the different airports. And then over here, it's like it's like a terrain map. Right, and then like we were, so the idea was, we were going to make like a flow, what's it called? Give me a sec. A flow field. So what happens is we arbitrarily made like a flow field from the different pixels of this map to guide like vectors of like if. Weather is unpredictable sometimes. So like we simulated that with like rain droplets. So we were drawing like rain droplets on like different parts of the map, and then like basically it's a terrain map. So like the different pixels and the colorations has its own like routes if you were to overlay the flow. But basically, the yellows and the greens and like the blues, like they're topography maps. But basically, like they have their own region to equilibrium. So like right here, like the different colorations would make them go into equilibrium, and this is like a full circle. Like it symbolizes like a hurricane or something, but it just came out that way where like when we put more stuff in the map, like we first like constrained it towards just the map itself, but you're able to like draw stuff outside of the map, and then eventually they go inside to the map region, and then they form an equilibrium of like the different the weather forecasts of like simulating rain droplets over time. So that was our whole dashboard idea, where we like simulate rainfall and temperature and the misery map among airports at different locations. So that's what we ended up doing.
That's super cool. So is that, what I'm not understanding, Cody, is the rain, the pattern of the rain when it kind of goes toward that equilibrium, is it sort of following that same values for the flow field?
Yeah, it just goes into like the vectors of the flow field is just like it depends on the terrain. So like it depends on the terrain and the background of the pixels. So I guess this part of like Mexico is like really like it's useful. So I don't know. That's what ended up happening when we like constrained it into the map, and then obviously we could draw some more, but that's what ended up happening. They all go into this little circle and this little circle right here.
Huh. Interesting. Wow, you guys did a lot of work. Looks great.
Yeah. Thanks. Okay, so real quickly, we have like a couple icons over here, and then we imported 3 images. For the 3 images, we did like a blend, and then we overlaid another image on top of that just to explain what's going on. And Muyang also added music where it lights up depending on if the music is loud or not. So this is just like an edge detect, very simple. And then now this is the real thing. So there's like an image underneath the image, but the image underneath is a blend. So it's hard to tell, but the image is actually it's like a I Spy kind of theme where like you're trying to be a detective, you're trying to find something behind what's in the image, and it's just like what you see is not really what's actually there, because there's like 3 images. The image in the circle is blended, and then the image that's at the background has lights that flicker on and off depending on the music, and you can't hear the music, but just I kind of believe it's there. And it's like flickering depending on the music. And then obviously there's like icons. And yeah, there's like little fragments of icons that they're supposed to be diamonds, but we were going to do it differently. So we just did arbitrarily random icons for the effect of some coolness, I guess.
Yeah, there is a lot of coolness. This would be cool in a concert or a huge projection, moving with the music.
Uh-huh.
So it's really rich. It's not sort of like with the asteroids I was talking about, that those trailing kind of blue sphere things would be sort of like the smoke thing on the asteroid.
Yeah. We were trying to do like an array of
That's
images.
Very cool.
Yeah. All right.
Yeah, no, it's very rich. It's a very rich thing, actually. I love the image that you guys found with those kind of strange chandelier things.
That was actually my vacation pictures. We went to a shop. So yeah. All right. We did a visualization of the Twitter, basically, using keywords Winter Olympics right here. And we took so we established a Twitter connection using hash keys, and then we did a listener, and then we got the keywords as well as the image of the username, and then we had an exit handler, when we shut down. So like real quickly, I'll run it. So this is like establishing connection, and then this is like the stream of keywords using winter and Olympics of like whoever wrote different Twitter feeds, basically, and then the visualization. Muyang, can you move it over?
All right.
Yeah, move the visualization over. There you go. So we post, so on top is the comparison between winter and Olympics. So this is the count of how many winter mentions and how many Olympics mentions. And then, like, you know, obviously people can say Winter Olympics in the same Twitter tweet, right? So, like, you know, sometimes, like, these images for both users are the same and both tweets are the same. And then we made, like, a word, I forgot what's it called, a word cloud of, like, winter and Olympics. Basically, this is all in real time. And then we made kind of like using the profile images of the usernames who use winter. Here is the winter layout, and then using the people images who wrote Olympics, we wrote, you know, we made the Olympic symbol over here. And then, Muyang, if you could explain your parts.
I loaded this Olympic logo, and then I selected the pixels only where the brightness is lower than the white, and then I drew the Twitter images over the area where the brightness is lower than 255. That's what I did, and then also on the background, a music is playing. The Olympic opening music I downloaded, and it's playing, and then the velocity or the direction of the snow is following the amplitude of the music. So it's jittering left and right according to the amplitude of the snow.
So did you have any challenges with Twitter only allowing you to grab certain amounts of data?
We just had a streaming feed. Not necessarily, because our keywords are really specific. So it wasn't like coming up with a lot of data. It was like, you know, if you saw the count, it was incrementing slowly, and it was dependent on, you know, current events, basically. We made 4 turrets and 4 enemies. We made a game, basically. So the turret class is an abstract turret class, and then Control F. So there's a turret called Rocket, there's a turret called Sniper, there's a turret called Area of Effect. And for the enemies, it's like the same, about the same thing. There's like a abstract class enemy, and then extend. So there's an enemy called Blockies from lecture, the Kinetic Art from homework 3, and the Rays from lecture, and the Spider from lecture. So what we did was we just made a game to show how all these things go together, and also in addition to that, we made we made an implement. So we have a word cloud as well. So we implement a library, and then we added more things to the library, where we, what's it called? Let me find it.
You guys implemented an interface, you mean? Right?
I'm not sure how to call it. Very hard to.
Yeah.
I don't have the verbiage.
It had to be
sorry.
It had to be an interface. Because in Java, you implement interfaces. So there must have been an interface somewhere that you guys created.
So yeah, we just basically made a word cloud out of the shape. So the way we run it is, so hopefully this runs. So the word cloud is basically reviews of the game from games from the Android store. So we just found like random reviews from the Android store. We made the shape out of the alliance symbol from Star Wars, and that's how we did a word cloud. And then the game, there's the game. So we call it Guardians of the Galaxy, and then this is like different routes that the enemies take to invade your fort. So we take, we go hard mode, easy mode, and then the routes, and then we go. And then we started the round, and these are the blockies from lecture, and then we have to slice. Sorry, I gotta turn the sound off. There's different so your health goes down. It's 16 now because we're dying. So we gotta do better. So we have to like buy stuff with the money, and the health goes down in your score depending on what you do. And these are the rays from lecture. So we're out of money, so we can't buy more stuff. But for now, we have to like accumulate money to buy more stuff. So these are the different types of friendlies, and I'm doing like absolutely atrocious for this game. But like you can move these guys. So like you could select this guy, and then you can move it, and then you could sell it if you wanted to. And then like these are the spiders from lecture, and they're going really fast. Hopefully we could survive the next round. But and then from there we could buy a sniper rifle. We could buy a launcher. The radius is like the radius of like how far they extend there. This is the Kinetic Art from Homework 3 that we brought back, and this guy takes a lot of health. So I don't know if like we're not going to survive, but we have no money, but we could upgrade it like depending on the precedence of like attacking blockies or rays or spiders first, and then we could like upgrade based on the fire rate, the focus, like the range of damage and all that, and just continues onwards. And then we have 5 health. It's red, and these are like the different enemies that go through the portals that we have to defend, so the health doesn't go to 0, and then that's when game is over. But these are the different types of enemies and different types of turret that we showed the extend function, and it goes on to 20 rounds. We don't have to show it, but we quit. We quit for now. And then we should have like the high scores. We played around with it, with the different like maps and the hard modes and the options of like, sound on, sound off. And, you could write your name in it as well. So go ahead and write your name, Young, if you want to show it.
So you guys sending the data to like a flash file or something? How are you saving it?
To Excel, CSV.
Yes.
Okay.
If you have any questions, we go into code. But like, I think we explained it through playing the game, maybe.
Yeah, I love how you guys always recycle other stuff from the class into your projects. It's awesome.
Yeah. That's it. Thank you.
Wow. You need the kitchen sink in there, yeah.
I mean, we had all recycled code because we can't go 3D with some of this code, so this is like the last ditch of effort to recycle all the code we can before we go 3D.
Yeah. I like the code recycling idea.
But, we did it in, obviously, Java, and there's like mouse buttons and like keystrokes for our visualization project.
So did you guys combine every single project you've done all semester in this final one?
No, I wish we did that. That'd be great.
I know you'd like that.
So anyways, so we mapped the entire music file in bins, like a histogram of like a distribution of decibels, if that makes any sense. So like there's 30 bins, and these are decibels. And, music is specific to 60 to 120 decibels, and we tailor it to the range of the min and max of each music file. So this is, for example, this is a Hans Zimmer. The next one will be like Beethoven. And then it's all different, right? Like how so the amplitude of each bin is determined by the bits of data that is in a time frame of 60 frames a second. So like it rotates around an axis. You could, obviously we could like change it up. But like you could tell that like it's like changing the amplitude determined by the frame rate and determined by the sample rate of milliseconds, and it's like changing, and we have like different colors and stuff. So this visualization is an engine block in space. That's the visualization, like without the car, the engine block in space of like different colors, and we just made the idea was to make a music player, like iTunes, where we import different like music, and it just plays through. And this is Isaac Hayes, for example. And we have like 6 different types of genres. So this one is opera with Pavarotti, and this we can like allow it to loop. so we could loop it to true. So when it goes to the end, it goes back to the beginning. Or we could loop it to false, and it goes to the next song. And then obviously we could also toggle like how far or how, like the reference of the mapping of the music file. We could change the fast forwarding and stuff. And this is jazz. So this is just different visualization of different genres of music for the variations and distributions of amplitude and decibels and bends. Sorry if that's complicated, but that's what we did. And the other visualization that we did for this was water droplets in space as well. So like planets are, I guess it's water droplets or planets, I'm not sure, but it's basically orbs are populating in space where like they like begin and end when it comes down to the different bends and decibels and amplitudes, and they like dance around basically. And then if you scroll up or down, like you can like see it propagate from like nothing into something like the Big Bang. And you have the pause button, so then the planets are like obviously nothing, and then like the bends are also nothing, but then you can also unpause, and then this is how it like changes. And propagation of like planet orbs or the engine block in space. So that's what we did for the 3D visualization. It's kind of complicated, but that's what we ended up doing.
That's
And
awesome. I think this is my favorite project you guys did all semester, because your projects are always really complex, but this one's also quite beautiful and elegant, right? So it's just a really nice combination of all the different things you guys learned, and it's really nice. I mean, I could see this being on a huge screen, projected live during concerts. That'd be awesome.
Yeah.
So are you going to
there you go.
Career and are you going to switch your career and become a creative computer person now?
I'm not sure. I mean, it takes a lot of work, and just the brainstorming of the idea takes quite a bit of days to figure out what we're actually doing. But yeah, I'm not sure. I like data. That's all. I like to process data, and like the visualization part is a plus, obviously.
Yeah.
And yeah,
very
what does
cool.
the x-axis here represent? Like, it's so much more dense on the left than the right. Like, what's going on there?
So it begins at around 60 decibels, depending on the file, and ends at 120 decibels. So obviously, the music would rather be on the hearing side without making you go deaf. Like that was the idea. And then the percussion maybe the percussion makes it like to the upper end of the higher spectrum, but it's usually like within easy hearing of any music file. So it's like around less than 100 decibels is where it's hovering at. So that's what we're doing.
That's cool.
There you go. Try to compete with iTunes here, but yeah, thanks.
Basically, we have 9 classes, and it was ridiculous how long it took to do this. But anyways, we'll try to go as speedily as possible. So basically, we made just 20 cities. We scraped the data set from how many listings there are from Glassdoor to find the average, and then we did a distribution of a bar graph real quickly, and then from there we calculated if you're single and in 2007 how much taxes you'll file given you're taking the average income average salary, and then we did federal tax, all the state taxes, sales tax, property tax, how much of the income you actually keep from your salary after tax. And there's like 4 tabs of like if you're married in 2017 or if you're married in 2018, how it changes and it like fluctuates based on current events, and how much of the total tax percentage so basically we go through the different cities, and then the pie chart changes as well as the bar graph and the line graph of standard of living, which is Washington DC is standard of living 140, and then the income adjustment, how much So this is your initial salary from the salary just initially, and then after tax, after standard living adjustment, after commute adjustment, and after you pay for your mortgage, how much you actually keep. So like, you can visually see how it decreases in New York. So just like you have this, and then it just goes to nothing after mortgage. And similar to like San Francisco or like, Texas is better. It's a little bit more flat. It's like you start with like a little bit meager, but then like you get to keep more. So that was the visualization we tried to portray to show a message of like, standard living and how grocery, housing, utilities, transportation, health, and services take away from everything. And then just we scroll through the different cities basically. So that's the first aspect of how you could, for every city you could toggle if you're single or married in 2017, 2018. And then we have job growth.
So what's the best one?
Huh?
Gotta give us so we know. We need to know. We need to know where to move. What's
Dallas. Apparently it's Dallas.
Dallas.
Yeah.
Excellent.
So basically, we could just figure out like which is the highest bar graph of the last tile right here of what you keep, and apparently Dallas you keep a little bit more. Actually, it's like Missouri, but Missouri. The thing is, Missouri has like crime, so like we'll get into that. So the next section, this is the panel of we did like visualizations for every category almost. So anyway, this is like job growth and population change in respect to job growth. So if population change is too high, this flower doesn't grow as much. So it's like relative job growth according to population change. So this one's like really high because people are leaving the city and job is growing somehow for Missouri. And then the flower changes respectively towards that abstract. And then this is just mean IQ and poverty rate. So the brain on the brain gets bigger depending on the IQ, and the hat gets bigger depending on how many bachelors there are. We highlighted it wrong, but basically we could just go through the different cities of like, brains and like how many degrees the IQ has. And this is violent crime. It's like a abstract visualization of violent crime where the bridge ricochets back and forth depending on how violent it is. It's like violently shaking. It's like a play on words. So like Missouri, even though it's like you keep more of your mortgage, it shakes a lot.
Where did the mean IQ data come from? Did you make that up?
No, we actually got it from somewhere. I could go through a data set, but like we got it from a source. I could reference it later if given time. I'm trying to go through our visualizations real quick, but property crime is basically how many your property is like the size of your house increases or decreases depending on it's basically what's it called, the median house price. So obviously, if the house is like bigger, you can buy a bigger house depending on what you can afford. But like it's a smaller house in Pennsylvania. But this is like property crime. So we're drawing graffiti with like random walk, like depending on like the graffiti line like is longer or shorter depending on how much property crime there is per city. Happiness rank is just the emoji of how happy people are. So some are like really frightened. So San Diego is like really happy, and like some are like just okay. And my screen's not big enough. This is supposed to be a sense of purpose. So this is Dallas. It like the sense of purpose gets like really on target, and then like for other cities it's all over the place. So it just increases or decreases depending on like the city, right? And then the financial health is like how much. It's basically the same aspect of visualizing abstractly after how much taxes you pay. So for other cities, like there's a bigger hole in the cash reserve because you're paying all this to taxes. So there's more particles of money flowing out from your money bag at the end of the day. And then social health and community. So community is how big. So the size of its recursion. So what we did was we took 2D recursion of circles where the size of the whole the size changes based on how big the community is, and social health is how knitted the community is. So there are two different aspects of like how big the community is and how tightly knitted the community is to visualize both social and community health. So these cities have like different visualizations of like how knitted and unknitted the community is and how big it is for like different cities. And then physical health is just flowers again, where we just like show more flowers and different heights, depending on the city, like just the physical health of like the city or yourself, basically. And then precipitation days is just rain, sun, snow. Comfort index, we had to change it, but basically we had some other ideas for that one. Air quality is the amount of smog for alpha changes depending on the air quality. It's really hard to tell, but basically the smog on the air changes depending on the air quality. The water quality, like, it's alpha again. So basically we use the water to portray how clean the water is, just like abstractly to show all this stuff. So, and then we have a word cloud where we scraped each city and like the sentiment analysis of like, basically, if it's expensive or trafficy or there's museums or stuff, and we scraped for every city and San Francisco and like a bunch of places. So like, yeah, so we did all this. I think that's it, team. What do I forget? I think I showed every thing. I think.
You showed everything, I guess.
Yeah,
that
was it.
That's awesome.
Yeah.
I have trouble believing that the mean IQ in some of these cities is so high, though.
I'll send you the reference on the chat or something. This one didn't make the cutting board. We had like a category. It didn't make the final cut, but basically we had like cars driving slower or faster, of particles, like more cars on the street, and then how fast they're going. It didn't make the final cut because we ran out of real estate for displaying gas price and commute times, but like we basically showed it in a bar graph for the final cutting board.
Yeah.
So we did a lot. It just didn't make it at all.
I think you guys did enough work, though.
Yeah, we just like one bar, but that's it. Thank you.